Hello and welcome to Tech Dictated. Today we are looking at the SR flip-flop. In the previous video we looked at the SR latch, and so today we've just progressed and we've added this extra circuit. We talked about two types of SR latches. There is an alternative circuit using a NOR gate and the first circuit using a NAND gate, okay? Not AND and not OR. NAND and NOR gates. That's what we talked about in the last video, and today we are moving on to the SR flip-flop. Now the SR flip-flop, the difference, as you will notice, is this clocking bit. Therefore, when the clock is low, regardless of whether you're inputting, you're setting, resetting, it doesn't matter. The memory will always save the last state. Nothing will change in your circuit. So when the clock is low, whatever you do to this does not matter because it will not affect the output. So we have a connection here where we have, these ones are the ones that feed in. So when you feed an S, this is the set, it feeds in NAND, okay? The output will be according to this, that will go into the NOR gate. And therefore, both the inputs of the NOR gate depend on each other. So whichever we find first, I will just explain just as I did before. So let's start with what we've talked about, okay? So we've mentioned that the state does not change, right? Till here. Let me start with that. Leave that alone first. Till here, regardless of what you're changing, it won't change the output. It will keep whatever is in memory the same exact way. So when these ones are both 0 and this is a 1, then that means you've not made any input. You've not added anything as an input, and therefore it will not change the status of what exists in the memory. But then when you change one input as a 1, then you are setting or resetting. In this case, we've changed the 1 here. We've added a 1 on this side, therefore we are resetting. If it's on this other side, it's setting, okay? So in this case, let me just do this so that you can easily view them. I have a better diagram, which I will share shortly, okay? So in this first one, we are resetting, and in this second one, we are setting, okay? Because we've put a 1 on this end, so we are setting. And then in the last one, this is an invalid state. It's not allowed in an SR flip-flop. Now let's try it out. So we have a 1. This should be a 1 for anything to happen. So let's set it. So a 1, a 0. So we have a 1 here and a 0 here, right? Therefore, when this is a 1, this is a NAND gate, right? 1 1. What happens when you have a 1 1 in a NAND gate? That we talked about. 1 1 will be 0, okay? And then 1 0 will be 1. So whenever we have a 0, does it matter? No. But let's see. Whenever we have a 0, whenever we have a 1, that's what matters. Whenever we have a 1, so I'm sorry, I used the wrong chart. So whenever we have a 1, so let's go back here. Let's remove this. Okay, we've not done that. Whenever we have a 1, so it will do exactly the same thing. Whenever we have a 1 in this gate, 1 1 1, then the output is a 0. Okay, so the output here will be 0. Okay, and when the output here is 0, then this output is fed to this, and we have a 0 0. And in a NOR gate, 0 0 translates to a 1 as the output. This is the output. Don't know if the O confuses. This is the output. So a 0 0 will be a 1 in this end. Okay, so I've removed this because I had confused. And therefore the output is a 1. So a 1 0, and this is setting because this is Q, this is Q naught. This is resetting side, setting side. Okay, and when we look at this, when we have our input as 1 0, as 1 0, the output is 1 0. So that's setting. Okay, whenever we have our input as 0, 1, I should have used a different pen. I don't know if this will be writing too big of, yeah, it's too big. So let me just write with the same pen. I hope you don't confuse, because I don't have, oh, I have a green one. But I have a green pen somewhere here. Yeah, so I think my green pens are missing. Yeah, so whenever we have, let me see. Yeah, this is better. Whenever we have a 0 and a 1, still black. Okay, whenever we have a 0 and a 1, right? Then this is definitely a 1, okay? Because the clock must be high for us to continue with this process at all. So we have a 0 and a 1, then we have our input 0, 1. And this is an AND gate. So let's go to our NAND gate. When we have a 0, 1, the output is a 1. So our output, then this one is for this, okay? They follow each other sequentially. Then whenever we have a 1 and a 1, our output is a 0, okay? That's going on well. Then we have a 1 here and a 0 here. Now, using our NOR gate, let's look at it. When we have a 1 anywhere, our output is a 0. When we have a 1 anywhere, our output is a 0. And therefore, this will be 0. And this 0 comes back down to this point, and that's our input. So our input here is 0, 0, and therefore our output will be a 1. So when resetting, 0, 1, that's our input, and the output will be 0, 1, okay? 0, 1, 0, 1, that's resetting. Now the state that's not allowed, let's look at that. 1, 1. We have a 1 here, and we also have a 1 here. When we have a 1, 1, this is a NAND gate. Let's use our table. 1, 1 will be a 0. So we have a 0 here. I don't know if I've started confusing you, but we'll have our 0 here. 1, 1, we have a 0 here. And both are 0, and it's an entry to an OR gate. Now, let's look at it. When we have a 0, 0, it can either be a 1, it can be a 0. So it's not really determined what the output will be. The output may be a 1, it may be a 0. We are not really sure. That's the SR latch, and that's the not allowed state. Therefore, the output can be a 1 or a 0, and then that's an invalid state. And so to simplify all this, okay, you can just draw it this way. Whenever the clock is 0, regardless of these two, we retain what is in memory. Okay, the current value is retained. Whenever the input is 0, 0, even though the clock is a 1, we also retain what is in memory. But then when this happens, we are resetting, and this we are setting. Okay, a 0 is resetting, a 1 is setting, because we've not included both of them. So one represents another. This means on the setting side is a 0. On the setting side is a 1. Therefore, if on the setting side is a 0, then on the resetting is a 1. On the setting side is a 1, on the resetting is a 0. And this last one is in an invalid state, because we do not really know which value it's holding as of that exact time. So it seems to have the same problem with the SR latch. So we are going to look at the JK flip-flop, which is also an advancement to the SR, to the clocked SR latch, or the SR flip-flop.